4.3. 4.3 is to finish this. Oh. Okay, so with the rest of 4.3, we're going to talk about expanding a little bit more, condensing, and then we're going to talk about some word problems, mathematical applications. Okay. 4.3, part 2. Okay, let's say that you have log base 4, 5x cubed y. Okay, 5x cubed y. I want to expand this. So we got to think about those 3 rules we talked about yesterday, and we need to expand it. So what would I do first here? What's happening with 5x and y? What's being done there?
There's a cube root.
There is a cube root. We'll get to that in the second step. Good, Dakota. Okay, so what'd you say, Lindsay? They're being what? They're being multiplied. So if they're being multiplied, when we break them apart, what do? We add. Good. So I'm going to say log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Now, log base 4 of 5, can anything be done to that? Anything more? No, 5 is my x, my term. What about this one? Log base 3 in front, because I put powers in front. That's what I put in front. So log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. That is as far as I can take this. That is log base 4, 5 times x cubed y expanded. That is the expanded version of that. Okay. What happens, this one's going to be more difficult. What happens if I have natural log and I have the square root, yes, of 3x minus 5 over 7. Okay? The square root of 3x minus 5 over 7. Okay? If we have division, what do we have going on when we expand? Good, Linz, yes. When we have division, we have subtraction. So I'm going to break it apart and say the natural log, the square root of 3x minus 5 minus natural log of 7. Now, natural log of 7 is as far as it can go. There's nothing else I can do to that. However, the natural log, the square root of 3x minus 5, I can break that apart. How can you break that apart? Not square them. If I'm taking the square root, what power do I have? Not the second. When I'm taking the square root, I have a power of 1/2. When I have radicals, if I have a square root, it translates to 1/2. If I have a cube root, it translates to 1/3. Whatever this power is that you are taking is the denominator on the fraction, okay? And whatever power's inside here is what goes there. Since there's no power inside here, it's 1. If this were squared like this on the inside, this would change to 2 over 2 like that, okay? Or if it was cubed, it would be 3 over 2. So when you have radicals, you have to be able to change them into fractional exponents. That came from last chapter. And from Algebra 2. So, if I'm changing this to a fractional exponent, that means I have this. ln 3x minus 5 in parentheses to the 1/2 minus ln 7. Am I done there? Why am I not done, Lindsay? Because of the exponent. So what do I do with all exponents when I'm expanding? Bring them in front. So I have 1/2 ln 3x minus 5 minus ln of 7. That is my expanded form. let's talk about one more. We're going to do one more expansion. Let's talk about if I have let's see here, log base 3, 4x squared over the square root of y. How do I expand that? Log base 3, 4x squared over the square root of y.
Would be subtracted.
Yeah, good, Dakota. So I'm going to say log base 3, 4x squared minus log base 3, the square root of y. Okay. Now, let's focus on this portion here. What can I do from log base 3, 4x squared?
Move the 2 in front.
Not yet. There's something I have to do first. What's happening with 4 and x? They're being what? Multiplied. So how do I have to break those apart first?
Log 3, 4, and log 3 x squared.
Yes, but what goes in between those? What's that? What, Lindsay? Addition. Log base 3, 4 plus log base 3x squared minus. Now, I have log base 3, the square root of y. How do I change that? What's that square root change into? 1/2. Okay? So then I have log base 3 y to the 1/2. Now, this can't be expanded any further, so I just bring it down. Log base 3 of 4. What can happen there, Dakota?
Move the 2 in front.
Yep, 2 in front. Log base 3 of x. And then what happens here?
Move the 1/2 in front.
Move the 1/2 in front. So I have 3 rules I have to follow for expanding and condensing. Those 3 rules never change. So you're just always checking for all 3 rules. Breaking it apart through division, through multiplication, and then exponents moving to the front. Okay? Now we're going to work on 3 different ones of condensing. So let's say they give you 1/2 log base 10 of x plus 3 log base 10 of x plus 1. They want us to condense that. So now we're changing it into something like this. Okay? What do I need to start with for condensing that? Look here. What can I condense first from 1/2 log 10x?
You gotta put that
Yeah, put the half back with the x for a power. So log base 10 x to the 1/2. Now, what over here can I condense first?
3.
The 3. So I'm going to put the 3 as a power of this. Now, what can I condense? The what?
X to the 1/2.
What do you mean the x to the 1/2?
Couldn't you make it square?
Oh, I can, yes. So I can say log base 10, the square root of x. Good. Now what can I do from there?
Square root of log base 10 square root of x times.
Yes, I need to multiply these 2 units together so that I have log base 10, the square root of x times x plus 1 cubed. This is that function condensed. That's as far as I can go. Let's try. Okay. 2 natural log x plus 2 minus natural log of x. What do I need to condense first? Square it. I'm going to change this 2 into a square. Natural log of x plus 2 squared minus the natural log of x. Now what do I need to do?
Make it a fraction.
Fraction. Good. Natural log of x plus 2 squared over x. And I'm done. Good. And then we're gonna throw one more challenging one. 1/3 log base 2 of x plus log base 2 of x minus 4. Okay, how do I want to start condensing this? If I were you, I would start inside the brackets first. Put what together? Yeah, let's put this together first. So I have this 1/3 still out here, but that's okay. And then I'm going to say log base 2 of x times x minus 4, yes? Like that? Okay. From there, what am I going to do? Do what? Yeah, but Linz, we're going to show that first. So we're going to say log base 2 of x minus 4 to the 1/3, right? And then Lindsay said this means we're taking the cube root of that. So your final solution would say log base 2 of x minus 4, taking the cube root of that. That is your final solution.
Let's try to get that one.
Yeah, that one's more difficult for sure to see and manipulate. Okay. Remind me again. Let's just talk this out because I think you can do this. Remind me again, if you have a table of data like X and Y inputs, how do I put that into my graphing calculator so that I can get an equation? Yes, good. I want to press stat. You want to clear list 1 and 2, right? Okay, so you're going to press second 1, comma, second 2, enter, and then we'll clear the list. Then you go back into stat and you re-enter your data. Then when you go to graph it, what do you have to turn on? The plots, the stat plots, which means you press second y equals and you turn your stat plots on. Okay, then you can graph your little stat plot that way. If you want to come up with an equation, a linear equation, or a quadratic equation, or a cubic function, how do you do that? Yes, you go to stat and you go over to calculate, and then you pick whichever one you want. You press enter, and it will give you all the information. Okay, because on your homework you're going to have some problems like that again too. Okay, that is the end of 4.2.